We are joined today by our presenter, Marius Rosu. Marius is the Senior Product Manager for the electromechanical product line at ANSYS. He is responsible for building the portfolio technology roadmap, as well as developing the product line long-term business strategy. Marius has over 25 years of electrical and electromagnetic engineering experience, including 15 years of research and a distinguished academic performance. I will now turn the event over to Marius.
Thank you very much, Jean. I hope everyone can hear me clear and see my slide deck. Good morning, good afternoon, good evening, wherever you are located. And thank you very much for taking time to come to our global webinar, Achieving ISO 26262 Functional Safety Compliance with ANSYS Maxwell. As probably you know, everyone was asking for themselves, before attending this webinar. This type of, talk is not unusual talk as far, a software simulation environment and specifically ANSYS Maxwell. Since, we recently been certified by TUV, and we're going to discuss a little bit later about that. The distinguished and very well known organization, global organization, certifying companies worldwide on automotive, standards. And here we are talking about the functional safety standard ISO 26262. We're going to discuss about what means, this certification for Maxwell and how Maxwell can help identifying risk, mitigating risk, and complying with these standards. What actually standard means for ANSYS Maxwell simulation. And I will appreciate your patience and the questions you have related to this topic. Assuming that not every single person in audience is familiar with functional safety standard, we're gonna briefly introduce the ISO 26262. We're gonna discuss how simulation can be of benefit, and the most important thing, to briefly present the ANSYS Maxwell case studies being defined for this certification process and being certified as part of ISO 26262 compliance. Let me share with you a couple of, well-known already qualitative and quantitative data. Why we need standards and why different market segments require, important, standards to be fulfilled. We see in terms of reliability in automotive market, the car manufacturers, they face a significant improvement on the reliability over, 20, 30 years, even more. And we can definitely see, that early 1980s, out of total number of cars produced per year, 1% to 2% failed. In early 2000s, hundreds parts per million failed. You can see in 20 years, significant improvement on reliability. And nowadays, we are definitely talking about parts per billion. Only very few objects, in this case, very few products are failing out of billions of cars. On the right-hand side, we see a very nice trend on the cost of electronics as part of the entire, cost, the total cost of the car. And this, we're going to bring us with, the thinking that more robust and more reliable electronic components as a part of the entire car needs to be provided. And in order to fulfill this type of, requirements, a specific, based practices needs to be employed to fulfill those requirements. Easily we can see early 1950s to 2030. 2030 it's a significant milestone in automotive industry, since majority of the OEMs, the car manufacturers, declared that replacements of a traditional, engine with, electric vehicle cars. In 2030, the prediction of the automotive electronic cost, it's almost 50% of total car cost all wide. That 50% from the total cost of the car requires a significant, attention and significant, standard formulation to minimize the risk, to be able to mitigate, potential, risk defined by electronic components within the car. But what is ISO 26262? If you search on the internet and any type of standard definitions, you can easily find the following, definition in ISO 26262. It's an international functional safety standard for the development of electrical and electronic system in the road vehicles. This standard has been initially initiated by International Organization for Standardization, very well known under the abbreviation of ISO, in early 2011, and has been revised in 2018. This is very important, as you probably understood from the previous slide, the rapidly growing of electronic components, system and subsystem within the car that require, the generation and creation of such standard for electrical and also electronic systems. In 2018, because of the impact of semiconductor industry into the electronic and electrical components and also systems, this ISO 26262 has been revised, and a new chapter has been introduced related to the semiconductor industry. That type of revision extended the ISO 26262 outside of automotive sector and moving into semiconductor and the high technology sector as well, and we're going to be able to see a little bit later about that as well. The major foundation of the functional safety standard for road vehicles aims to address possible hazards caused by malfunctioning behavior of electrical and electronic system in vehicle. And it's not only the system, but also their corresponding subsystems. Finally defines guidelines to minimize the risk of malfunctions and ensure that electric and electronic components perform their intended function. These are the three major keys of the ISO 26262 for the final product. And here I'm talking about the cars. I'm talking about, the car, system and subsystems and components. But also let's think about, ANSYS Maxwell. ANSYS Maxwell, it's a software simulation by nature. As a software simulation, it's used to design components and also to generate characterization of various components to be integrated into systems. If those components and subsystems require to fulfill the standard requirements, then the Maxwell software, any simulation tool used to design those components and equipments needs, to obey the same type of, standard requirements. And this is, the bridge to understand how ANSYS Maxwell can play a significant role in ISO 26262, and mainly, defining those guidelines to minimize the risk. And everyone usually familiar with ANSYS Maxwell and any other simulation tool can understand this, defining the guidelines to minimize the risk. It's a collection of best practices using the software to be able to identify and to mitigate those inconveniences. But at the end of the day, the question is, do businesses care about ISO 26262 certification? With this type of, ISO certification, the car makers can definitely improve the safety of their products. They can minimize the risk of the product reliability, as we've been able, to see in the last 40 years, and definitely use it as a competitive advantage on the market. Not only mentioning, the reliability and our safety product, which is the safety car, can significantly reduce the number of recalls, can significantly reduce the number of maintenance of these cars for a longer period of time. Global businesses adopted the complex ISO 26262 standards, and this type of business complying with this standard has been seen across regions. For instance, Biotechnology, just to mention a few examples of businesses embrace this ISO 26262 certification, is the first company in APAC region to receive this type of certification. TUV, which I earlier mentioned, it's a German organization, it's a global organization, well known and well recognized, certifying businesses compliance with this certification. Certify Panasonic electronic equipment development to be compliant with this safety regulation for automotive development. As you can see in these examples, you don't see only automotive OEMs, you don't see only automotive car makers, you also see their vendors, and their vendors on electronic components. With extension of ISO 26262 into semiconductor arena, you're going to be able, to see more high-tech companies and electronic companies obeying, these requirements and embracing, the need of 26262 certification. What is 26262, how this operates, and what are the parts of ISO 26262, and most importantly, how these parts and chapters can influence or can impact your own design using software simulation. Without going into details and going into an ISO 26262 class, the certification process define the items involved in the definition, involved in identification, and involving in the guidelines generation for those requirements. ISO 26262 starts, with definition of items, elements, faults, errors, failures, functional safety. Then it's management of functional safety, identifying and defining the hazardous events, defining the safety goals against those hazardous events, and what is more important, defining the criteria for automotive safety integrity level. It's very well known under abbreviation of ASIL. And this automotive safety integrity level goes from level A, which is the lowest, to the level D, which is the highest. The next 5 chapters, from concept phase to product development system, product development hardware, product development software, and the operation and service, are falling into the safety life cycle category. Everyone is familiar with the life cycle. Life cycle generate, this type of, design profile, a V-design profile, going from a technical specification, going into architectural type of, topology selection, moving into system integration and technical requirements for individual components and subsystems, moving into the proper design of those components and bringing these components together into the system and subsystem. This is the place where the system simulation, the software simulation, plays a significant role, because the software simulation will going to comply with the technical specifications and the specific topology selected by the design. And then we're gonna design the component which will further be integrated into the system for validation and verification. And this is where Maxwell, ANSYS Maxwell, can help and prove can be compliant with ISO 26262. Supporting processes, objectives for integral process supporting for safety life cycle. And last but not least, the automotive safety integrity level. Again, defining the level of risk reduction, and also, prevent, specific hazards which previously has been identified